This is Sung, and I'm the Principal and Director of Sky Academy. And in this episode, I want to continue on with the work that we've been doing on probability. And this time what I want to do is look at mutually exclusive and non-mutually exclusive events. And this really has to do with the addition properties of probability. Okay, in other words, what you can do is add the probabilities of two different events together if they are mutually exclusive. All right, and then we'll also look at what happens when they're not mutually exclusive. But let me go and explain what I mean by mutually exclusive. Okay, so mutually exclusive events. All right, two events are mutually exclusive if both cannot happen at the same time. Okay, so I'll give you an example of what I mean. If you had a deck of cards, all right, and in that deck of cards, it's a full deck, so you have 52 cards, of which you've got 13 cards off 4 suits. You can either have diamonds, hearts, spades, or clubs, right? And each deck has 13 cards, the cards from 1 to 10, plus a jack, a queen, and a king. Okay, so you've got 52 cards. The probability of choosing a heart, well, that's one probability. The probability of choosing a spade, that's another set of probabilities, right? You cannot choose one card that is going to be both a spade and a heart. You just can't have two. You can't just have one card being both a spade and a heart at the same time, right? So we say that the probability of choosing a heart and the probability of choosing a spade are mutually exclusive to one another, okay? So, where you've got mutually exclusive events, the probability of choosing either a heart or a spade, in other words, the probability of A or B together, right, is the probability of the first plus the probability of the second, okay? And we use this little symbol here, all right, and that symbol means the word union. And what union means, it means adding together the probabilities of one with the other, okay? It's the combined probability of both, right? So again, the probability of choosing a heart will be 13 out of 52, all right? Because you've got 13 cards that are hearts out of 52 altogether in the deck. The probability of choosing a spade, again, will be 13 out of 52 because you've got 13 cards which are hearts and 13 cards which are spades. And this probability of A combined with B is going to be the probability of a heart or a spade being chosen, okay? So the probability of choosing either a heart or a spade is going to be simply the probability of the first plus the probability of the second, right? 13 out of 52 plus 13 out of 52. And that's going to be equal to 26 out of 52, all right? So the probability of choosing mutually exclusive events will just be the sum of those probabilities together. I want to now turn our attention to non-mutually exclusive events. And non-mutually exclusive events are events, let me read it out. If it is possible for one event to occur at the same time as another, they will not be mutually exclusive. Alright? So let me go through what I mean by that. Here we have the probability of choosing a heart as being 13 out of 52. What would not be mutually exclusive with that would be the probability of choosing a royal card along with that, okay? So a royal card will be either a jack, a queen, or a king, yes? But of these cards which are hearts, 3 of them are going to be royals. So there's an overlap of 3 cards. Do you see that? So that overlap means that they're not mutually exclusive. So how many royals are there? There'll be a jack, a queen, and a king for each of the 4 suits. All right? So 3 times 4, there'll be 12 cards which are royals. Okay? Now, let me just rub this out for a second because I want to go through something with you. Remember how we said that there was an overlap? So there are, in fact, 13 hearts. Yes? Of those 13 hearts, 3 of them are royal. Yes? And, well, there's 13 altogether, so 10 of them must be not royal. Yes? Of these royal cards, 3 of them are hearts, which means 9 of them, 3 plus 9 is 12, 9 of them must be non-hearts. Okay? So, the way we do this is we basically, the probability of them being a heart or royal will be the probability of them being A plus the probability of B minus the overlap. And see this sign there? That means intersection, which intersection means the overlapping bit. Okay. So we want to take away the overlapping bit, and the reason why we want to take one of the overlapping bits away is because if we don't take the overlapping bit away, we will have counted the overlapping bit twice. Alright? So, the probability of a heart or a royal is going to be the probability of a heart plus the probability of a royal minus the probability of both. Does that make sense? So what that is, 13 out of 52 plus 12 out of 52 minus 3 out of 52, which ends up being 25 minus 3, 22 out of 52. Yep. Which is exactly what we get when we add 10 plus 3 plus 9. We also get 22. Okay? So, when we've got non-mutually exclusive events, alright, the combined probability of either a heart or a royal, remember this is union, which means combined. The combined probability would be the probability plus of one plus the probability of the other minus the probability of the overlapping region. Does that make sense? Cool. So basically what we've gone through today is the addition property of probability, which means that where you've got 2 events, you can add their probabilities to get their combined probability of one or the other. Alright? Where they're exclusive, you just add. Where they're non-exclusive, or they're not exclusive, you also have to remember to take away the overlapping bit. Okay, good. Let's leave it there today for this episode. Thank you very much for watching, and I'll see you on the next episode.